Hello guys, welcome to the video. I hope all of you are doing well. In this video, we are going to discuss our question, the curious case of Benjamin bulb. Very interesting question, so I hope you give it your best and understand it with all your hard work and brain work. So let's see our question. We are given n number of bulbs and they all are initially switched off. A weird fluctuation in voltage hits the circuits n times. In the first fluctuation, all bulbs are toggle. In the second fluctuation, every 2th bulb is toggle. Every multiple of 2 gets toggle. Same in the third bulb, every multiple of 3 gets toggle. Okay, so you must be wondering what toggle means. So the bulb which is off get turned on and the bulb which is turned on gets turned off. So in the input, we are given n number of bulbs and we are required to print all the bulbs that will remain on after nth fluctuation. So let's understand our question better. So what we are given? Let's see. We are given n. Let n be 18. So what n denotes? N denotes two things here. One is the number of bulbs. So my first bulb, my second bulb, third bulb. So I'm gonna create n bulbs. 6, 7, 8, 9th bulb, 10th bulb, 11th bulb, 12th bulb, 13th bulb, 14th bulb, 15th bulb, 16th bulb, 17th and 18th. So these are total your nth bulbs. Now in the input we are given n and we have talked about this. N denotes both the number of bulbs and the number of fluctuation. Right. I would like to write it here. What n denotes? Number of bulbs and number of fluctuations. So this is what n denotes. Now, what we know that initially all the bulbs are off. All bulbs are off. Well, that is given to us in our question. Now, we know that n number of fluctuation will happen. So let's see what will happen in the first fluctuation. In the first fluctuation, all the bulbs will get toggle. That means that initially all the bulbs are off, right? Initially all the bulbs are off. So now all the bulbs will turn on. Are you getting me? Yep. So because every number is a multiple of 1. So all the bulbs got toggle. Now in the second fluctuation, all the bulbs which are multiple of 2, 2, 4, 6, 8 and of course 2, 10, 12, 14, 16 and 18. So they will toggle. Now in the third fluctuation, 3 will toggle and its multiple 6, 9, 12, 15 and 18. Let's see more. In the fourth fluctuation, 4 will toggle and its multiple, that is 8, 12, 16. Now in the fifth fluctuation, 5 will toggle, 10 will toggle and 15 will toggle. In the sixth fluctuation, 6 will toggle and its multiple will toggle, that is 12 and 18. In the seventh fluctuation, 7 will toggle and its multiple 14 will toggle. In the eighth fluctuation, 8 will toggle and its multiple 16 will toggle. In the ninth fluctuation, 9 will toggle and 18 will toggle. Alright, now that's important. In the 10th fluctuation, 10 will toggle, but as we can see, there is no multiple of n that is less than n, right? So only 10 will toggle. Now same for 11, there is no multiple of 11 that is less than n is present, so only 11 will toggle. Here only 12 will toggle, 13th will toggle, 14th will toggle, 15th and 16th will toggle, 17th and 18th. So such that what we did, we toggled all our bulbs, and now what we have to print in our output? In the output, we have to tell. Let's see our output first. Wait. Yeah. So we have to tell which bulb will remain on. So which bulb will remain on after n fluctuation. So I can write after n fluctuations. Right. Simple as that. So now let's calculate which bulb will remain on. Okay. So here 1 was initially off, and after first fluctuation it got on. So we can say that 1 will remain on. 1 will be part of our answer. Okay, now 2 was initially off, then it got turned on, then again it got turned off. So no, 2 will not remain on. Now for 3 was initially off, then it got turned on, then again it got turned off. Now let's see for 4. 4 was initially off, then it got turned on, then again it got turned off, and then finally it got turned on. So 4 will also remain on. So 4 will be part of our answer. 4 will remain on. Now for 5. 5 was initially off, then it got turned on, then again it got turned off. For 6 too. It was off, right? Then it got on, then off, then on, then off. So it will remain off. So no need to consider 6. Now for 7 was initially off, then it got turned on, then again it got turned off. Alright. Now for 8 was initially off, then it got turned on, then it got turned off, then it got turned on, then it got turned off. So it will remain off. Now for 9, see it. So 9 was initially off, then it got turned on, then it got turned off again, and then it got turned on. So 9 will remain on. So can you notice a pattern here? So as we can see, wherever there is odd number of fluctuation, wherever there is odd number of fluctuation, or you can say whichever bulb got toggle odd number of times, right? Odd number of times toggle. So if a bulb got toggle odd number of time, that means it will remain on. Okay, that's fine. So for 10, as you can see, 10 got toggle even number of times, so it will not be in our answer. Even 11, it got toggle even number of times. For 12 too, it was initially off, then it got turned on, then off, then on, then off, then on, then on. So it will remain on. Alright, now let's try to find odd number of toggles. So as you can see, in 16th, okay, 16th, initially it was off, then it got turned on, then off, then on, then off and on. So it will remain on. Okay, for 17th, off, on, off. So it will remain on. And for 18th, it was initially off, then it got turned on, then again off, then on, off, on and on. So it will remain off, right? Because there are even number of toggle that is happening here, and we want odd number of toggles, right? Now, one more thing that I want you to notice. What I want you to notice, that currently what we notice, that if our bulb toggled odd number of times, that it will be in our answer, then it will remain on. But can you notice something, that all the bulbs that remain on, that remain turned on, are perfect square. So what is a perfect square? Okay, perfect square is a complete square of a number. For example, let's write our answers, the answer that we just got. So they are 1, 4, 9 and 16. So we know, what we know is that, I'm gonna create some space, right? So 1 is a complete square of 1, right? And for 4 is a square of 2, 9 is a square of 3, and 16 is a square of 4. So all the answers that we got are perfect square. Okay, so that means what we are required to do is to calculate perfect square. Simple. But now you must be wondering, why is that? Why perfect square is our answer? Okay, we will discuss about it. So let's take a number and let's try to calculate its factors. Okay, so let's say our number is 24. Okay, so all the factors of 24, 1 into 24, 2 into 12, 2 into 12, 3 into 8, right? 4 into 5. What else? What else? 5 into 4, 8 into 3, 12 into 2, and 24 into 1. Okay, so can I say if this is n, if this is n, right? So we got total 2n factors for a number which is not a perfect square. Now let's see for a perfect square. Okay, so let's see for a perfect square. So let's take 36, and we know 36 is a perfect square because 6 square is 36. Okay, so now let's calculate its factors. So 1 into 36, 2 into 18, 3 into 12, 4 into 9, right? And what else? 6 into 6. Okay, 9 into 4, 12 into 3, 18 into 2, and 36 into 1. So this time, if you consider this n again, if you consider it n again, we can say we got 2n plus 1 factors, right? 2n plus 1 factors, right? N plus 1 this. So as we can see, in a perfect square, we are getting odd number of factors. So that's the reason we need, that's the reason, as we know, that's the reason perfect square got odd number of toggles, odd number of factors. That's why perfect square is in our answer. So eventually what we just have to print in this question is all the perfect square. So this question seemed hard in the start, but this question is very easy because at the end what we have to calculate is perfect square. How we can calculate perfect square? So I will initialize I with 1, and what I have to calculate all the perfect square that is less than equal to a number n. Okay, and we will simply print perfect square of I into I and increase the value of I. Okay, so this was it for our code. Let's run it. Accepted. Now let's submit it. Perfect. So this was our question. First we calculated and tried to find that why perfect square is our answer. So then we try to derive it using the factors by calculating the factors of a non-perfect square and a perfect square, and eventually we realize that y perfect square will be our answer. So if you liked this video, do not forget to like, comment and share. Thanks for watching.